To welcome you all and thank you for taking the time to join us today. I will first address some logistical issues for the session and then introduce our speaker, Rick Haynes. We have a lot of material planned for this 1-hour webinar, so the audio will be muted for the remainder of the presentation to ensure that we are able to get through the entire presentation in the time allowed. We will not be able to hear you, but you will be able to hear Rick. If Rick cannot answer your question either during or at the end of the webinar, we will either email you or call you with a response. There will be a recording of the webinar available on our website within 48 hours. You will receive an email with the link to the recording. I will now introduce our presenter, Rick Haynes. Rick has over 20 years of Lean and Six Sigma experience as a practitioner and is one of Smarter Solutions' senior instructors. Through his career, he has certified as a Master Black Belt, Champion, and a Yellow Belt, along with teaching and certifying professionals in all the Lean Six Sigma areas. He is a Master Degreed statistician and has taught statistics in the Penn State University system. He has worked in all levels of the business from entry level up to a site engineering manager. His life experiences and skills will provide you with an engaging discussion. Again, thank you for joining us today. At this time, I will turn the presentation over to Rick Haynes.
Hello, everybody. Thanks for coming today. Like Ann said, we'll go through this. Will be about an hour. Like a lot of things, I probably prepared too much for this. We got a lot of slides to go through. But I really want you to use the interface to type in any questions you have. There are a few moments of interactive natured behavior I'll need from you through here. So what are we going to cover here? This is about data collection and how it changes for different uses. But I'm going to start a little bit about basic data collection, finish up with the different uses. So here's our first poll question. If you would go look at it, is data collection an important topic? So if you would pick one of those three on your screen, and we'll post the answers. If you've never done a webinar, this is how it goes. Give you a few more seconds to do it, please. All right, would you close the poll now, Anna? Let's see what it looks like. Of course, you all said yes. So the next question is, what was wrong with it? Why was that a bad data collection? So if you type a couple comments in, if you have any thoughts on why was that a bad data collection? Well, let's go through them. I didn't see, oh, there's some people writing in, thank you. What do we have? The leading question, too general, too much. We all knew the answer. But I think that's a clear one. One is the order of the questions, right? It started with yes, the answer I wanted. What's the other one? Let's talk about my sampling space. Let's say I sent a request out for this webinar to 1,000 people, and 200 of you sign up. And then I say, what percent of those 200 think data collection is important? Guess what? All of them. So it's going to make it look like a really strong belief. The problem is my sample space didn't include all the people that didn't think it was important, if that makes sense. All right, that's one. And it was also binary. They were yes or no questions. What's the best chart I can do is a Pareto chart on that. But that's the thing about looking at the question you ask sometimes impacts the answers. So what? That's why. Now let's talk about data collection. So thank you for all those answers. Ann, was there any really good ones in there I missed? I should ask that before I move on. Not specific, no measurement scale, but again, it was an attribute, so you really don't have a measurement scale. No definitions and methods. I like that one. I'm a Deming believer in operational definitions and what's important. How do you judge it's important or not? That's a good one. Let's move on. Data collection methods. I've always looked at data collection as a heartache in my whole career as an engineer, scientist, and a Lean Six Sigma practitioner because it's early in the process, and if you mess it up, you get a bad answer. So I've learned to treat it like a design of experiments. Create a worksheet, paper or electronic, provide an example of what it's supposed to look like so people fill it in right. Always allow for comments and observations. And if you can, have preset or pre-chosen entries so everybody is consistent. And provide a lot of guidelines. How often you want it done, what gauge to use, the purpose, and the big one on when it ends. I have on here an example of a data one. I created this for this seminar. But as you look at it, it's a sample data collection sheet for, say, a call center, and you're measuring a sales call. A date and time. But notice for the middle four, you have to mark or choose from a list. So I will get a clear discussion. Nobody can put a different choice in. Now those codes are shown below. I would generally put them on the back of a data collection sheet, not the front, make it run the whole length of it so people know what they are. The duration, if you'll notice, it's minutes, but it's decimal minutes, and a comment page. Now, I would have handed this out with this top line filled out like this, so the next person to fill it out is going to basically mimic the first line. It's a good practice to do, and that way you get data that you can use. We're going to talk about some reasons data collection goes bad a bit, but having data that they fill it all out and you can't use it is one of the biggest problems I've faced. There's some more common errors. And if you have one that I missed, feel free to type it in and Ann will bring it up with us. But a free-form data entry, you just tell them to enter stuff. What was the call about? A horrible thing to put on, because you could have 5 people write 5 different things that were truly the correct or the same item. It makes it very difficult to analyze, and that's why in the example we had circle the appropriate one. Non-standard rounding or units. Some people put it in minutes and seconds. Some people put rounded minutes. Some people put decimal minutes. It's very difficult then to transcribe the numbers and analyze them because you don't know what they're doing. It's very difficult to compare. Non-standard entries, we've covered that. And wrong data. That's always a winner. When one of the people chooses the wrong gauge, the wrong tool, and actually enters the wrong data, you can't tell when you get that sheet back. So that's generally the fault of the experimenter or the practitioner. They weren't clear enough with the team what they wanted to measure. There's a lot of common errors. Each of these I've got a callus because of forgetting it. What are lessons you can learn? Now, smart people learn from others' lessons. It's one of the reasons you may have chosen to come here. These are ones from my life. I had data collection on a chemical process with no comment field. We had like 8 of us on our team all around this big conveyorized chemical process collecting data because we were having a huge quality problem. The quality problem appeared and went away during our data collection, and we thought we were there after our desk and found nothing. It turned out we went back down there, and the operator goes, "Why are you guys back?" He said, "Well, the problem happened, and then it went away, and we didn't find it." We said, "You know, this light comes on the panel every time the quality goes bad." We went, "No." He goes, "Watch." The light came on, the quality went bad. He says, "I don't know what the light does." And we found out later that it was a water addition going on. But you've got to let people write down anomalies that they see. Data collection without standard entries. I had 2 weeks of a data collection that people had wrote all over the place with all different stuff, and I couldn't do anything with it. How about disgruntled? Fake information. They don't want to take the time. They think you're wasting time. They just put in numbers that they like. You can't tell when you get that data collection sheet, so you have to work hard to make sure they understand the value. And the other one that's even tougher is scared employees. They fake the data so that they don't get in trouble because there's no way they're going to put an out-of-tolerance number down. And I've seen that happen so many times. And you end up working with the people to make sure that there's no penalty. We'll talk a little bit about working around it. We got some in here. People put in wrong time numbers in. That's another data collection issue. But what are your concerns? You collect data to run an analysis. All data is collected for a purpose, generally to do a decision or hypothesis test. A good practice is to dry run the data collection before you commit a whole bunch to your workforce. What I've done is me or a team member go down there, just either manually put some data in or fake some data based on what you know and the way you think it will be entered. Then type it into an analysis software, do the analysis, and try every test you want. Because I've had times that, wow, I can't really make that comparison because I didn't collect a piece of data. Or I wanted to know if there was an operator impact, and I didn't collect the person. So go do all your tests on the dummy data set, and it's always made me change my data collection practices. I'm sure some of you have faced these too. Next interactive question here. Got another poll. How much data is enough to collect for a decision? I got here 5 choices. I want you to pick the one that's right, then we're going to talk about what's wrong with this data collection too. So please take some time and enter them. And by the way, there is no wrong answer if it's the one you use. Great, we're getting a lot of response, and I appreciate that. It makes it more fun when people are paying attention. So, Ann, if you give it about another 10 seconds and cut it off. All right, so was it share? Now, there's what people put, and you know something, I really like that result. I teach Lean Six Sigma, and there are all these sample size calculators that they go through. And in my practice, I never use those things because they always ask for more data than I have either time or money to collect. And you guys put in, over half of you said that's all I can afford to do. And afford could be money or time. But I do think the business is a bigger constraint. And the next winner was 25. Now that is a great one to put up. But now let's talk about why was this a bad question? Why was this a bad data collection? Any thoughts? Put down a reason. If you enter a 1 or 2 things here of why that was a poor data collection. What do we have coming in here? Are they at the top or the bottom? They're all over the place. Enough is not defined. Now there's another person I like. Enough. Because you know what? Oh, here's a pet peeve. Oh, the use of other. That's a great one too. Because other is what lazy people use every time they do a data collection. Let's go look at some things here. Why was it? Well, one, it was mixed numbers and text. Numbers are so much better. I mean, if I use 5, 10, 15, 20, 25, I could make a regression or a model to see what the most popular choice is. When I put numbers and text in, I forced it to be an attribute analysis. The best I can do is a histogram, a Pareto chart. But let's look at where these answers come from. These weren't randomly selected. What's 12? You see 12 a lot in some SPC classes and in simple T testing for one sample, is you need at least 12 to do a test. Well, that's still arbitrary. I think 25 is the most common one taught out there because they say that's the minimum sample for whatever. But really that number derives from the point where the standard deviation estimate uncertainty starts to level out. It asymptotically reaches a point that any more samples do not give you a significant benefit. And that's where 25 comes from. Most of us, if you were in my class, I'd draw a little picture and show where that's right. But that's where that comes from. Now, what's 100? Well, that's to represent the case that there is sometimes an organizational number that if I don't collect this many, they won't trust the answer. So it's more about belief than statistics. We dealt with a bottle manufacturing company. Their number was 2,500, but they made a lot of bottles, so it was easy. But if you didn't have 2,500 data points, they wouldn't talk to you. And in the class, we had someone that was making decisions on 5 data points because they made prototypes. And the last ones are what I think really drives sampling. So thank you for that. Moving on. What's the most frequent question asked about data collection? Well, I always find it to be how much data do I need or how long should I collect data, which is still how much data. Now your standard answer is, and if you were a Lean Six Sigma student, you probably heard them say it depends is the answer to everything. Well, it does depend. Now I'm not going to spend a lot of time on sampling theory here, but let's talk about what it depends on. The question you want to answer, how much variability there is in your system, collection time, collection cost, is that it? Well, that's enough for now. What it depends on for the quantity and the question and the variation. Well, there's a simple function here. There really is an equation for every test, but generally the sample sizes, the factors are the same in all tests. And you see the n is a function of 1 minus the alpha risk, or the confidence you want. More confidence, more samples. 1 minus beta, or the power of the test. More power, more samples. The standard deviation. If the standard deviation goes up, you need more n for the same decision. And it's 1 over delta, where delta is the difference of what you're trying to detect. Or say it's the sensitivity, and it's 1 over that. The less sensitive, or the bigger delta gets, the smaller n gets, so you can see there. But this is a general guidelines for all testing. What's time and cost? Well, like we talked about, generally the constraints are not statistics. It's about how much time I got, when the problem's got to be solved, how much money it costs to collect data. But so more often than not, we're trading the power of the test to reduce the sample size. Now, you may have to reduce your deliverables. You can't detect that small a change, but you can detect one a little bit bigger. Now, we spend a lot of time in classes about this, but in a Lean Six Sigma project, my history says you hardly ever find a factor that's just barely significant. They're usually monstrous p-values that run 0 in Minitab, or less than 0.01. So really, n wasn't an issue. For a very good test and a good data collection, a significant factor will still show up. How are we doing? Any more questions popping up, Ann? You guys are overwhelming Ann here with lots of questions, and I appreciate it, but she's having fun with it.
They are not coming over.
All right?
No, we're good right now.
Just, if you want, Ann, just click on one and answer, and it should go away. You can remove them.
Okay.
Let's talk about risk now. This is a simple hypothesis test. You may have seen a class, but the confidence is the ability, if there was no change, you detect it, and you made the proper decision. Where the power of a test, lower right, the process really did change, and you did recognize it. So we're really managing the other two errors. Now, which one's most important? If you look on the lower left, HA, that's where we decide the process changed, but it didn't. That's what this type 1 error is.
I have one question.
Oh, here we have a question, Ann.
Yes. The first question to answer is my measurement system capable?
Now, capability of a measurement system, I didn't decide not to put that in here. What's odd is there are cases that you want to look at that, especially if you're making small changes. Most data collections, though, are using a gauge that's considered acceptable for the process. Now, I would tell you that if you're an advanced practitioner, you're considering that early. Most people, though, will use the gauges that the business is using to do the initial data collections, because that's the source of data that you believe a problem is happening. So that data source made you believe there's a problem you're investigating. I usually start there. I know in our model in Smarter Solutions here, we ask you to do your first data collection before the measurement system analysis, because we want you to validate the problem as seen by the management today. Then go to the measurement system analysis, because honestly, if you fix the measurement system, all your historical data now is hard to apply. So generally, your first data collection was with your current system. Then you assess data, the quality of the data or the measurement uncertainty is one of your factors for potential improvement. But either order is fine. Thank you for that. Risking, what's the right amount of risk? Generally, everywhere I've been has been a 5% alpha risk or 95% confidence for decisions. The only one in my history, we worked in nuclear safety, we used 99.9% confidence or an alpha risk of 0.01 for a nuclear accident, which that's a good thing. But even for material building and stuff, we still use 95% confidence. Now, the power or the beta risk, I've seen it all over the place. It's not been consistent. A few years back, we polled all the contractors in our company and found people that dealt with power down to 50%, beta risk at 50% and beta risk up to 5%. My history was around 20. Forrest, the CEO, his ran around 10 and 5% at IBM when he worked there, but there isn't a consensus on the power for a test. Now, which one's more important? I would propose that alpha is the more important one, especially for the Lean Six Sigma crowd, but with respect to decision making. And that's why we focus more on it. If you make an alpha error, which says it's a significant factor, but I missed it, said it wasn't, well, I keep looking. But a beta error, if you think it was significant, you end up, oh no, it's the other way around. I got it backwards. I get, with an alpha risk, you say it's significant when it's not. What you do is the risk, why that's important is that would cause you to stop your project or think you solved the problem. You will lose credibility and the business won't improve. But beta risk, if you make that error, which means it's a significant factor and you didn't catch it, you continue your investigation and project, so you'll probably come up with it later. That's why we don't manage beta risk as tightly, because you can give a little bit there and not be hurt as bad in the end. All right. More about variation in time. Data collection should be conducted in a short period of time, enough to hold the unimportant factors stable. Again, think like a design of experiments. If you're testing the difference in materials, you want to run all your data collection when nothing else changes. Same people, same piece of equipment, because all you're testing is raw materials. If you're looking at a call center script or a new IT solution, you'd want to keep the same type of calls and the same operators to see if there's a difference. You see what it's the same concept of holding everything stable that you don't want to see an impact of, so you get a better investigation of the factors you're involved in. And again, if you're testing differences in operators or people, you want to keep the transactions and the conditions the same. But by doing this, you get the data that you collect is more usable for the decisions you want. And if you've studied design of experiments, you'll see the similarity there too. Why does the question matter? Well, if you are comparing groups, there's different concerns than if you're trying to measure a change of a continuous variable. But what if you're looking at groups? Well, if you're comparing groups, you must ensure that you have similar amounts of data for every group or every level of the factor. Say 10 random transactions per person running it, or 12 measurements per customer run, or 8 or 9 per day. But the point of it is you want to get about the same sample size in each group so you can do a fair comparison. 2 in one group and 25 in another will make the unbalanced nature of the sampling will cause you sometimes phantom significance, I'll call it. Now what we're talking here is called a stratified random sample. You define your groupings to be in the ratio you have in big production, and then you sample randomly within each group. This can also be a great one if you have an uneven product mix and you want to check the whole year's impact, but you're not running something very high today. You would sample it at a higher rate, so the ratio of the data in your sample is the same ratio you would have over a whole year. But it's a very powerful way to sample. What if you're doing a continuous process, say a conveyorized process or something that's running just all the time? When you have a continuous process, that's a random process. So you don't need to randomly sample. You can sample on a fixed period. So again, if the process is stable, there's a random output, only varying due to the nature of your process, you can sample every hour, every shift, but on a sample period that's consistent, the data is still random. And the advantage is you also get data across the whole period of time you're operating. So again, the question changes how you might collect data. And I get back to the simulation. Every time I run one, I grab natural data, even if it's historical, plug it in there, write down what people do, and then try to run the test to see, is this enough change to see the significance I'm looking for? You're almost doing a sample size calculation with real numbers. But then take it and actually perform the analysis. Can I do an ANOVA with that? Can I do a regression with that? I've done it a number of times, collected numbers, but by chance the way they were collected, they were actually text characters because somebody put in 5 minutes instead of a 5, and now it's a data column that's text, and I can't do a regression anymore. So this is the kind of things you play with before you get there. But a number of times I've collected data that I couldn't use and had to go back again. We'll talk about 2 different looks at data collection, then we'll get into the purpose of the data collection. But you may or may not have heard of these. Heisenberg's uncertainty principle and the Hawthorne effect. All of my trainings always talked about Hawthorne, but Heisenberg's uncertainty principle, I don't know, it's quantum physics, and maybe I might be a nerd for talking about it, but they're each important. One talks to Heisenberg got to the point that the act of measuring a process changes it. Now, it really came from position and velocity of quantum particles, but the point is still good. And the Hawthorne effect is when you can see a system change indirectly, improving performance just by observing it. It came from illumination changes in the Hawthorne Works plant in Chicago, that they got temporary productivity enhancements as they raised the lights. The social scientists came back and reduced the lighting, saying it was really too bright now, and in each case performance improved, showing that it wasn't the light, it was the act of caring and making a change. But with Heisenberg, can the act of collecting data really change the quality of your data? And there's a couple of things here, but they all deal with having trust. A worker manually collecting data may not execute the process same way because they're taking time to do the data. They run it differently. Use observers. You may have a manual collection that they won't write down the non-compliant stuff, and I've seen that so much. Well, that one was out of spec. We won't write that one down. Let's let it go and get the next one. And the third one, if you're watched, they behave differently. I find they're always slower. They'll pull out a procedure. They don't even know where it is normally. But each of those, to stop that, you have to remove penalties for noncompliance, make sure that no names are involved, code the operators, and have them trust you, that you're not going to put them in trouble, that you really want them to do the process like they normally do. It's hard to do this, but you have to stick with it. Now, Hawthorne. Yeah, the study says if just process performance changes just because you're looking at it. I've seen a number of Six Sigma projects. Now, I haven't had this one, but I've had students. The minute they charter the project, go discuss the team with what they're doing, the problem disappeared. Now they think you're watching. It does happen. But really, to do this, you have to warn the workforce that there's a risk of this happening, explain why you got to have them do it the same way. Another good one is to track quality, throughput, and cost in the background while you're running your testing. Because sometimes you'll see the throughput will slow way down because they're not running their normal process. But that's a check to see if they really did change behavior. And the other one is perform a good process capability review before the project starts so you know how it's supposed to be. And you will recognize if they're not executing the same way. Those of interest to anybody? I hope so. I think about them. Next poll question here. Have we covered the purpose of this webinar? Now, answer this one. You're already seeing it's sort of trivial. So please answer something. It looks like everybody's putting not really. There's some no's in there. You can close the poll on this one. We're going to have another discussion of why. What's wrong with this? I really have been talking about things that weren't on the title for the webinar, which is really about data collection for a purpose. Let's talk about purpose now. If you have longer questions about data collection in general, please enter them. We'll talk about them at the end if we have time. But we're doing good right now. I'm going to talk about a project. Now, most of the discussion at this point has really been directed at project-based stuff because that's the decisions we're making. Again, the considerations are risk, cost, and the time. The stratified sampling to make sure you have similar data counts to the conditions that are in real life, I think that's a powerful one I learned late in my career. Always use a plan and a data sheet to reduce errors. I found that doing that, having a briefing, talking to everybody about the importance of doing it exactly how you do it, really helps you get a better data set so you can believe it more. Testing it, that's another lesson learned I got late in my life. Doing a quick data collection, usually by myself or with a team member, walking up and making sure we can use it. And then the big one in bold print, never collect data on an unstable process. I know in our Smarter Solutions Lean Six Sigma model, you always get stability before you move on to testing for causes. It's real important because if it's an unstable process, you can have a significant change that was an out-of-control condition that may show up as one of the factors. Something come up here, Ann?
Yeah, I've got a couple of questions.
Let's try one.
How will you know the process is unstable without data?
You do have to collect some data, but you assume the process has some, and you just take what you have. Now, most of the data collection I was talking about at this point was a structured data analysis looking for potential causes. The data collection for stability is just the output of the process, or at least it's sigma your project metric. You just take what you got and see if it's consistent over time. So yeah, that's true. You still are collecting data for that, but I'm talking a deeper one earlier. Ann, is there another one?
It was actually the same question by a different person.
All right. Well, thank you very much. Process control. My career started early in this, but if you're collecting data to manage a process, in our model we call that the 50-foot model, down at ground level, you're typically using the data to do a shoe-heart control chart. In this case, this is not business data, it's process control data. You collect data on a single process, avoid mixtures. Don't take the data off multiple machines, go to only one data stream, one operator necessarily, and collect it rapidly over time. So your frequency is quite rapid. You are assuming that the process is in a good place when you're collecting data. In other words, you want to keep the average where it is and keep the current standard deviation good enough. You want to sample frequently enough that most of the data, or most of the performance between data points is stable. You're looking for a step change or a drift. So it's very frequent sampling, generally one data point at a time, or an X bar in our chart. We have a bunch of samples and a period and a bunch of samples. But the goal is to detect every small change in the process so you can change it. Yes?
Yes, we've got a question. Don't you need to collect data on a process to determine if the process is unstable?
Yes. But that's what I'm talking. You in a high-level business sense, you just collect the data that the company has, generally looking as it's historically collected or as it's going on right now. Processes may be unstable over the long term, but you want it stable over a detailed data collection when you're looking for causes. Now back to shoe-heart. The clue on this is not an SBC class, which you could spend weeks on, but any variability in the process that you put in a subgroup, you've defined it as acceptable, which means you can hide problems by the way you choose to subgroup or sample in the process control realm. That's why we generally do rapid collection over short periods of time, because you really want to be sampling faster than you know the process could change. All right? Jump into a scorecard. Any process control questions in there?
No.
All right. Data collection for a scorecard, a dashboard, a performance report, a status report, a production meeting, or anything like that. So this is you're really collecting data over a bigger process set to see how it's going. I look at some of this. This is looking at the data or performance as the view of the customer. You want to know how the business looks at it or the customer looks at it? Generally to do this, if you're trying to consider that type of data collection, you list all the known sources of change. Does it change with shifts, with people, with raw materials, day of the week, hour of the day? You list all those and find out how often they're changing. Then look at the customer view. The customer, like let's say you have an hour-by-hour problem or a shift difference. Your customer could care less. The customer sees product or services coming out the door. So you have to then group the data in a way that you collect all these things that you have to change in your process to do your job. That is now acceptable, and that should be in a subgroup. So generally in this method, we take a big group of data, calculate an average and a standard deviation, and plot them each on an individual's chart, and then do a capability assessment. That's how you collect data for a scorecard. So again, it's over a longer period of time and a group of data, because anything that's happening within the subgroup, you say is part of my business. Now, we call this the 30,000-foot view of reporting, but it's also the way Dr. Deming looked at a system view of the process versus Schuhart, who did a process view. It's a very powerful look. I just hit the wrong button, so we're going back again. Sorry about that.
I've got a question.
Go ahead.
Here. Is there any technique for collecting data for profit?
For profit?
For profit.
Profit's a fun one. Yeah, with profit, you're already averaging over some period of time. Generally, the period you'd sample, it's based on what the business wants. Most businesses look at it monthly and quarterly. Now, profit really is the sum of all the daily profits, the weekly profit, and you compile it in a month. So you would generally calculate the profit. Now, profit by a percentage is generally preferred because it's a percentage of the overall business, and most of our pricing is based on a margin rate. So that's a good way to track profit. You can also measure profit as an absolute number as long as it's relatively stable. Profit percentage is generally consistent, but profit value is increasing as the business increases and if your business is running well. So again, percentage is better. And with all control charts, you're better off trying to track something you expect to be consistent over time. The only difference in the data points is variability. So yeah, we'd probably do the profit percentage, plot it probably monthly. I wouldn't do it on any shorter period because most financial systems don't accumulate that number but monthly. All right. You want another one? Go ahead, Ann.
Okay. How does the data collection process change for small sample sizes for small businesses with limited production levels?
Small samples. Again, if all the data you have is 5, then you've got an adequate sample. You'll find the statistics behind it. What they do is they will adjust to the small sample size to make it more difficult to make a decision. So small samples, you can't make as small a change as detectable, but you take what you have. Like a control chart with 8 dots is still better than not running it, even though you can't make a conclusion on many of the run rules with 8 data points. So you just start with what you have and measure it. Now, it really isn't part of this class or this webinar, but 8 data points is okay if it's continuous data with a good measurement uncertainty you've checked, and you measure the performance and the capability with a control chart, probably an individual's chart, and a capability analysis using a probability plot, because 8 points is enough to verify a potential distribution, and if the 8 points are stable, you will find that it gives you a pretty good estimate of performance. Now, comparing something with only 6 data points means 2 samples of 3, and that's generally very difficult. But if that's all I have, that's all I have. We did deal with a company that made antigens, grew things, doing test pilot plants. They decided to productionize a process based on 3 data points. The cost was so high, but you know they were successful because in that case 3 was enough. When they put it on a probability plot, you could see that the yields would never go beyond what they considered acceptable. So yes, you deal with better statistical tools and have to be a little sharper with your pencil with small samples. I'm going to jump into what we call the 30,000-foot level. This is the scorecard discussion. And I've spent a little more time because I believe that's one that we as practitioners weren't taught as well. I know I wasn't taught until I'd been a black belt for a long time. The problem with using Shewhart control charts on the business metrics, which are multiple product lines, multiple processes, multiple people, because it'll always be out of control if you don't do it right. So we're going to call this the 30,000-foot method. When we have aggregations of data across many processes, multiple days, many people, many shifts, lots of stuff. The 30,000-foot means we're looking at it at a high level down at the business, such as a customer might see. An example, call center delays. How long they're on hold prior to getting answered. What's the customer see? They see your company as a single entity that's got to wait. They don't know that this is a slow time or fast time. They're looking at the business, no matter what's going on, how long does it take to answer? Now, if I know that I have hour-to-hour issues when the workday ends, at lunchtime, and maybe the evenings, I know it changes, but I'm managing my people to keep it consistent. You would just average the hold time over the whole day. And look at that report. The average hold time and the variability seen by my customers would be the right way to go do that. But if you're a manager, you're looking at a lot more detail in the process. I might want to collect data at a lot higher rate so I can look at different staff, different hours of the day, different types of calls, So if I'm collecting data for a manager's view to run the process, I would want a higher amount of data collected and more frequently, because I want to have data to answer every question that might come up. But as a scorecard or a performance report, I don't need so much data. I'm more going to take a little less samples over a longer period of time to get a better estimate of the overall performance. Phones could be the other example here, the other one we could look at. You're looking at the quality of a product or a phone. The customer just, it worked or it didn't when I got there. So I'd be looking at that as the scorecard metric. But a manager, business people are seeing a lot more discrete issues. Raw materials, suppliers, people, shifts, design changes. So if you're doing for a scorecard, it's the top one. You need infrequent data over a long period of time. But if you're looking for process control, you're looking at more frequent data. They're both valid views. I'm going to throw out a couple slides we had from one of our other courses here to talk about another visual way to see what I'm talking about. If you've got inputs into your process, the black box called company, and outputs to a customer, scorecards are generally looking at the data that are outputs on the right. You sample the outputs less frequently. If you group them, you group a long period of time together. That's the data collection for a scorecard. Now, if I'm a manager or a Lean Six Sigma project, I'm looking at measuring every input to look for changes. I'm looking at my process, trying to find when small changes are occurring that might affect the output. But that's not the way you look at a scorecard. Traditionally, businesses look at the inputs in the business on their scorecards. Their performance reports, they're doing at weekly staff meetings and monthly, and it always looks horrible. The reason is that data isn't meant to be looked at that way monthly because there's too much going on. You really want to look at that more in a shoe-heart method. We really want to be looking at your job as a scorecard to be looking more at the output. Because really, scorecards are not about causes. They're about estimating the overall performance. So generally, we do scorecards and performance reports, which are infrequently sampled with a lot of randomness in them, to get an indication of a change. So then I would go back and look at the inputs and the company factors, or in other words, more detail. So back to the earlier questions, what if you have to collect data to even judge stability? You're really looking at the high-level stuff, at the outputs. You'd have a more complex data collection plan when you find something wrong and move down to look at the input quality and the process quality. We're getting close to the end. So again, scorecards start high. And this slide reminds me to mention something. A data collection process should not be targeted at causes all the time. I dealt with one of our clients up in the Midwest with an insurance company. They were trying to measure their process, see if it was consistently run over time. It dealt something with claim processing. But their data collection was every claim, who did it, what was it about, how many errors they found, and they were collecting it on every one because they said, well, if I find an issue, I want to immediately be able to drill down and get the cause. But what that was generated was a huge amount of work for their workforce because you really weren't using most of that data. So our recommendation really is, if the question's overall performance, scorecard or dashboard, just collect enough to get an overall feel of the process. It's like taking your temperature. Have a data collection plan ready to go the minute you see a change in that, then collect the more detailed data like we talked about earlier. So what are the high-level business metric types? You can see here, quality levels, lead times, design time, overall enterprise-based metrics. They're not about a single process or person. We collect those slowly, or let's say more infrequently over a longer period of time. Now, the one thing about these metrics, when they go bad, when you have an out-of-control condition, you really don't have a cause. You haven't collected them to find causes. You're measuring an overall performance. Think of them like something like a check engine light. When it goes on, you don't know what the problem is, but you immediately troubleshoot it. That's what we use scorecards and dashboards. Measure it so you'll know that it indicates a time to look deeper into the process. Now, using this paradigm, we recognize lots of factors that go on all the time. These factors, the shifts, the changes, the people, raw material, you have to do those to stay in business. This scorecard measuring infrequently over a long period of time or grouping days and weeks together forces those to be in a subgroup, therefore they're considered to be common cause or part of your process. I think I've really covered what I want to do now. I got a slide or two left, but I think I've covered this topic enough. I'm going to move down what I've covered. I think we did cover what we wanted. And I missed there was a question. I don't have a question in there I wanted. Ann, would you post the last question, please? For some reason, I didn't. I must have hid the slide on my presentation. This is my last data collection. How did you hear about this webinar? Gave you a couple choices. Now, this I considered a relatively good data collection, even though it's got other in it, and a couple of you said you shouldn't put other in, and that's not bad. But I only get 5 choices. That's a constraint of my system with a limited number of characters in each. So did you get an email to you? Did you get it from somebody else or find out from another source? We actually did paste it on Facebook, and we have 0. Yeah, Facebook may not be for professionals, and a couple got it from other places. Well, I appreciate that if you post it now, close it, and show people. We always wonder, now, why is this one good? Well, see, this is a question we want to answer on marketing. How do you market your services? How do you reach people? It's always of interest, but most marketing is a broadcast. You never know how it is received. So I appreciate your input. This will help us direct our marketing plans. Let's see what we covered today. Data collection concepts and lessons learned. We talked about faults, problems, ways to get around them, and the importance of a data collection process or sheet. Treat it like a design of experiments. Talked about common questions that come up in data collection, a lot about how many, and that's always a big one because data costs money. We talked about 3 uses. For a project, if you're trying to make a decision or find significance, again, very detailed, over a short period of time where you manage the process, keep it stable, that you only allow the things you care about to change. And we talked about process control, where you want to focus on sampling quickly so that you're sampling quicker than things can go wrong so you can detect any small change. Sure, we call those assignable. Because in process control, when you see a process change, you then adjust the process to bring it back where it needs to be. And the last one we spent a little more time is data collection for scorecards or performance reports, dashboards, where the goal is to sample a little less frequently because the goal is to be over health. Don't collect data to have cause analysis. You're just looking to do a capability assessment and a stability assessment of your process. So generally, infrequently, grouping a lot of data together, calculate a mean and a standard deviation and plot those. To the end of my prepared material. And are there any outstanding questions? This is also for you to type in any questions that you might have. If you choose to leave before we go through these, you will find a survey. Please answer it when you're exiting. Questions, Ann?
Yep. Is a small sample size good or large?
Well, again, I'll tell you that some of you wrote good is an undefined thing. What's good enough? If you make the right decision, I'd call it good enough. More data, is, we always say, is better, but there's some point that you have too much data. For me, it's probably in the thousands of data points of a single group. But I'm comfortable in projects and in business with sample sizes of 8 to 10, and I don't really get concerned over it. That's enough that you get a reasonable standard deviation estimate, and I've seen to make good decisions. Now, that's assuming continuous data. For attribute data, my thumb rule is you need about 100 times more data points than you do when it's continuous. So if I'm looking at pass-fail data, good, bad data, I probably am looking for 500-600 data points at a minimum before you can make a measure of the % defective or such as that. Just think about it, with 100 points, you can only get integer percentages. So you need well over 100 points if you're going to make a good decision on defect rates, occurrence rates, such as that. Another one, Ann?
Would you use BPOM to automate the data collection?
BPOM is an acronym I don't know. But let's say it's talking about automated data collection. Most automated data collection is tended for process control. They're very rapid, collect a lot of data. There's no measurement entry error because it's electronically coded. The problem with that, though, generally is automatically collected data from a process has a, oh, and I just forgot the term, a time correlation. It's called auto-correlated. You collect data so fast, there actually is a correlation between each data point. Say it's a call center and wait time. If you're checking it every 2 minutes and the wait time's 5, you can't go from a 5-minute wait to a 0. So you always, in automated data, the harder part is to not take all the data, but to either take a frequency of like every 10th or every 100th point so that you've broken the auto-correlation, because each data point needs to be independent for a good data collection. The other option is averaging and taking an average of standard deviation over a long period of time will also break that auto-correlation of automated data. Yes?
I have another one. How would you recommend normalizing scorecard data for processes significantly impacted by seasonality?
Seasonality is a tough one. The simple answer is if you have clear seasons, retail generally have the Christmas season and the non-Christmas season. You can consider tracking each one as a different metric to track. How am I doing now and how am I doing at the other season? But that's not real satisfactory at times, especially if the seasons drift up and drift back down. If you know your business, what you do is you adjust each one to the seasonal norm and take a ratio. What am I above percent or above or below a predicted model? That's a good way to look at seasonality. Now, if seasonality isn't yearly, but let's say it's a weekly seasonality, Mondays and Fridays are different than Tuesday, Wednesday, Thursdays. When you have a cycle that's a bit shorter, we generally recommend each cycle you take an average and standard deviation and track them, because if the mean changes within the cycle, the mean chart would change. If the cycle amplitudes change, the standard deviation would change, you detect it there. So those are two reasonable answers. The other one that people do that's complex is an exponentially weighted moving average chart for seasonality. I know it's been said to do it. I've never been happy with it, but it is another option. You got another one, Ann?
Yes. Can you explain the power 1B?
Oh, the power. Beta risk, if I go back to that, I'm not going to go back to that. Beta risk is the risk that you should reject the null hypothesis, but you don't. In other words, you don't think the process shifted, and it really did, or you say it's a non-significant factor, but it really was. That's called the beta risk or the type 2 error. The power of the test is 1 minus beta, which says that's the power to detect a change. So you say the process changed, and it really did. It's the opposite side of confidence that there was no change. So you can look at it, it's like a confidence estimate, but when you say 95% confidence that you will know that it didn't change. The 5% risk in the alpha is the thing that it changed and I missed it. So the beta and the 1 minus beta are the opposite side. Now, it's a really confusing thing because we don't use it enough, mostly just seen in sample size calculators. I'd say reach out separately to me if you want a better discussion on that. Yeah? We have another one?
Can you explain how variation included in a subgroup is considered as acceptable?
I wish I had finger puppets right now to talk to you about that. Let's talk about an X bar and R chart. X bar and R chart where you take a small group of samples, say every hour, wait an hour, take 5 more samples, let's say, wait an hour, take 5 more. The variability within the subgroup, those 5, in an X bar and R chart, you take the range, max minus min, and that becomes the measure of your control limits for your average chart, or the X bar. So the fact that the variability in the subgroup is which would be R bar, or the average range, is what is used to calculate the control limits, or to define the natural variation in the X in the means. Now in an IMR, an individual's chart, it's the average difference between sequential points, or that subgrouping defines the natural variation that's used in the control limit. What I'm really meaning is in all of the control charts, anything that's averaged into the point is considered natural variability. You're trying to detect changes in the amount of variation in the subgroup or in the mean of the subgroup. I hope that helps. Next one, how do you convince managers that design of experiments must precede data collection rather than follow it? Now, I didn't intend to say that. I'm saying that the concept that you use for design of experiments to manage the data collection period is what you should use. That in a design of experiments, what you do is you list all the factors that you're going to change, and you find a way to change them. But everything that didn't make that list, you're supposed to work very hard not to let them change during your test. So use that concept. The stuff that you care about evaluating, allow it to vary during your process. But don't change the other things during your controlled data collection. I've done things like buy a bigger lot of raw material so I can run the same lot. I'll shift when I'm doing my data collection because I don't want that to impact the answer. It's things like that, so it's not a DOE. But what you did bring up in my mind with that question is a design of experiments is the very best tool for a data collection plan. If you've got a whole bunch of stuff going on and some of your factors don't happen very often, create a design of experiments, use that for your data collection plan, and collect 5 for each of the observations, and then wait till the next one comes up. So you really can use it for a data collection plan and just collect data to fill out your matrix. So that's sort of an advanced concept. What do we have here?
A few more.
Alpha risk is more important than beta. That comes up earlier. I think because an alpha risk means you think you solved the problem, but you didn't. And that's why we stay away from it. I think that's about it. How's our time running? We're about 4 minutes left on our hour. Any more questions? Looks like they're, oh, here we go. It's historical data as analysis. Can I use it? Should I still use short-term data? What you got me to is a topic I chose not to put in here. The quality of the data sources are available to you. I started with a premise we're going out to collect data for these things at this point. But if I want to look back at the quality of historical data, I would much rather use historical data if I can, because you get a lot more of it real quickly. You don't have to wait. So the idea of I don't have enough time or cost goes away. Now you really have generally large data sets. The risk of it is you may not know the context of the data. You don't know what was happening that day. You may not know who was running. You may not know there was a power outage or a water problem, or there was a fire in Nebraska and you got a lot more insurance calls. All you have is a number. So there's a risk in not knowing things that are actually changing back then. Another one is if there's bad data, there's no way to check it. And the other thing about historical data is you don't always know if you got it all. And I've been caught up with that. I took data out of the logs of one and ran a whole Lean Six Sigma project, decided I should go back and really do an observation and write some down and verify the data collection path. And I found an event, we're trying to reduce the time of work stoppages, that I wrote it down, went back the next day and found it wasn't in my log. I found out why and just found out the operators get in trouble with work delays, so they just quit counting them. So the fact that I just didn't have all the data in my historical stuff, and that's the risk. Hope I answered that well enough. Do I have time for one more, Ann? You guys, we got a lot of questions. If we didn't get to it, I'll send you a note about an answer. And if I think it's a really great question, all of you will get it.
Okay.
What's it say? I can read it. What value to assign to the data mining as compared to data analysis? And how should you collect data in support of them? Well, data mining is, by definition, looking at historical data. There is an art to data mining because you have to be able to discern between a correlation and a causation. And we see a lot of it in the news today. We call it big data analysis. But data mining, you have to have a very good tool. A Minitab would work, and there's better tools out there that handle bigger data sets. But Excel is a lousy tool for data mining because it doesn't handle a lot of data. Generally, what you're looking at is small changes in the patterns and the correlation. So data mining is generally multivariate. You're looking at the effect of 2 and 3 things at a time. For most data collection for projects, scorecards, and process control, you're really more focused on single main effects and potentially maybe an interaction. But data mining is looking for more complex relationships. So you start with 1 million data points in a lot of those. Data mining is an art, but data collection for scorecards is more of a, so what's the opposite of an art? It would be a skill. So there's intuition in mining. There really isn't in this other part. I think that's where I'll wrap it up right now. I appreciate your time. I hope you enjoyed it. I hope you learned something from it. You will get an email from us. This webinar will be available in a day or two. We'll get an email with the link to it if you want to watch it again. If you ask, we generally don't give the slides out at the end of a webinar, so I won't be doing that. But you'll all get a note if there was questions that were outstanding that were quite good. I appreciate your time, and thanks for listening.